thanks a lot for having me. I'm really excited actually to talk about it. And so don't hesitate to interrupt, because I think it's more interesting when you get the question directly. I work for 8 years actually in the population modeling world. I work at the University of Southampton, more in the geography department, and then in demographies at the University of Oxford, where I'm finishing my PhD, we hope, at one point. So I'm in 4th year, but I also work as a research assistant on different projects, and I'll talk about it more. But I wanted to check with you because I know, so this is my supervisor, Doug, and I know that he came here, so I wanted to check with the room who was at his talk. Okay, so there's going to be some similarities. I'll try to present it a bit differently. And some some similarities, some differences, because we work a lot together, so it was a bit hard to understand, how to make it completely different from his work. So the topic is population nowcasting. Did he explain the word, for example, of nowcasting? I don't see it. I'm very happy. I'm going to explain. I love this word, so I'm going to explain why we're calling it like that. And so I'm going to talk about population data, digital revolution, and modeling. Here it will be very interesting for I'm going to try to, I have one way of modeling, and I would like to hear if you have other ways. So I'm going to present the problems more in a way such that you can also, we can maybe exchange on that, such that, to just inform the modeling strategies. I'm going to explain population response to crisis. So once we have the data, then we model it, and then what is the findings that we have from it. So really going through the entire data science pipeline. And the last step will really be to understand the ethics of what we're doing. And I'll explain more because in the end, population counting is the most simplest things, because we know, like when I'm presenting to people that don't understand statistics, it's so easy because people understand what we mean, it's how many we are. But it gets very complicated and it's very political as well. And so that's why I found that this is really a topic that is interesting, because you have really this intersection of data, society, statistics, governance. So I hope that this maybe gets you excited for the talk. So I count people, and so the way it is actually still done today is by actually doing door knocking. So how many of you have participated to a census? Okay, that's a lot. Okay, so here, because I haven't, so I'm very excited that you have. Here we're going to talk about census, but on the really population counting part. So census is way larger. It's like understanding society, was here it's really like just counting people. And in a lot of parts of the world, it's still done like manually by counting everyone by meeting them. And here it's quite important, and I want to insist in meeting them, because it's really like the government that meets its citizen. So in the census, there's more than just knowing, informing, but there's also like inclusivity in it. But in some situation, and here I'm going to talk about those cases and even more. In some situation, it's like actually hard to get the count of people, either because there's violence or conflict happening, for a while, so you can't, and the government can't control this area anymore, so you can't access it, and so you can't deliver services if you don't know the number of people that are there. In some places it's very remote, and so you can't really access those places, or let's say it's too costly to send surveys there, but you still want to know how many people there are. And that's work that I've done in the Amazonian region. And then the crisis setting, and crisis setting is because on one side, you can't like send surveyors because it's very dangerous to them, but on the other side, it's also like demographic change. It's moving so quickly that having a clear picture of what's happening is really hard with people on the ground. So, So, coming back to population nowcasting. So, this is the word that I wanted to bring because I find, and I think it's applicable in different settings. Nowcasting is like, forecasting. You probably knew backcasting, or it's more in economics field, but it's like when they're checking their assumptions towards what happened before. And now casting is really knowing how many we are now. So it's trying to kind of like make the distance between collecting the data and getting the findings the shorter possible, or more. There's 3 steps. The event happening, the data collection, and the findings shrink, such that we know in real time what's happening. And I'm going to talk about it in 3 different settings where we shrink more and more the time. Wait, okay. So the first one is filling the census gap, because the census is every 10 years, and in some cases we can't cover the entire area, so it's just like filling the gap that the census, or even the census can't happen, so just having a picture at one point. Then, and this is more with satellite imagery. And I think that given the time, I might talk about it quickly and then we come back to it if you're more interested by one of these 3 areas. So you have this temporal resolution that we're trying to like shrink, having a picture. Then we have a census, but we want to update it because the census is every 10 years. So we want to have a picture that is every year. And so that is more with administrative records. And that's work that I've done in Colombia. And then there's quantification of force displacement, and here, depending on how much you saw quite a bit already with Doug, so I'm not sure I want to spend too much time, but I'll cover it quickly, and this is more social media or mobile phone. And without further ado, I'm going to start with the first one, which is satellite imagery to fill the census gap. And here, I'll talk about work that I've done in Burkina Faso. And so this was working directly with the SATS office there. And what was happening is that they were doing in 2020, that was the COVID time, was locked in my bedroom doing this work of, they've done the census, and they could not cover those areas in green because there were some insurgency going on there. But we still want to know the number of people because, and that's where it's a bit tricky in terms of policy, is that you can't send necessarily like people representing the government there, but you can still send like NGOs people. But NGO people need to actually know the number of people to do like vaccination campaign or like understand where people are. And so yeah, I was working with the National SATS office here to do that. And here, I cut off the model because I wanted to hear from you what do you think you would use if you were in front of this kind of situation. So there was two stages in this modeling question. One was we have all those census areas that we know, which are more in the south part. And so we have those census units that are small, and we know geospatial covariates from it. So we know the number of people, we know the geospatial covariates, and we want to predict in those areas where we don't know, but we still have the geospatial covariates. And you don't have to answer, because I wanted to make it a bit more interactive, but like which kind of model you would think you might use it to do this transfer learning, I think if you use learning.
I would probably use the first one.
But which kind of model? Because so the idea is both trying to estimate an area where there was no census, and then there was the idea of predicting as the final resolution. So we had 2 goals in modeling, and we used 2 different models. And so yeah, I don't know if you have an idea of how you would do first transfer learning and then disaggregating in like smaller units. And as a plug, you heard already about what we've done because I think Doug already presented to you. But so, and it's interesting that you bring the image processing because here we decoupled because we're considering that we're not the best in image processing. So we don't have computer vision expertise in our group at the time. So we're using products that are done by other researchers, such as delineating buildings. And so this is really heavy computer vision work. We use their product, and then we do statistical modeling, because with the idea that there's so little information and so much variety, so how many, like the geospatial covariates are how many buildings there are, why are the roads, like where are the night lights. In sub-Saharan Africa, it doesn't really work, the night lights, so we have very, very little information on that are directly linked to population counts. But we do have information, because it is true that close to a road you're going to have more people. We have now height, also done by computer vision people. So we do have information, but it's quite sparse. So it's not in terms of unit. We do have a lot of units, but it's quite sparse, the level of covariance that we have. So we use more like statistical modeling here to kind of like embed all the uncertainty in it. So yeah, that's the first one. And I just wanted to plug that. So we use statistical model, and I try to see in a context where actually I know the number of people, which was the Colombia census, if it does work. Because before we were more like, we need something, we were going to come up with a model, we would do only like cross-validation within the sample that we have. So it was hard to know exactly if this kind of approach worked. And what I learned from it, it does work, but it is very like, very not precise. And for example, if I increase the sample size, I would not decrease the inaccuracy. So it's really like you get a sense of roughly how many people you are, but so far, with the approach we're doing and with the covariance we're using, there's a limit to how we can link covariance with the number of people. Also, potentially Colombia is a setting where there's way more variety of usage of building, so that might be also a case that makes it harder actually to tackle. But so yeah, so just to say that, I mean, if you have computer vision people, maybe you would have idea on how to extract more information, but so far, there's a level that we can't really breach it.
The errors you're reporting here, at which geographical unit are they sort of? So like the median error is like upward of 100%, which just looks quite awful. But is this like, you know, if it's a very small unit?
It's a very small unit, it's the enumeration area, and then I went bigger, and then, yeah, it's bad. It's not that good, but yeah. And yeah, I learned here as well that actually like some more machine learning was better when there was more information, but as soon as the information was biased in the covariance, the model would like reproduce the bias rather than correct it. But that was also the point of the article. Another thing is, and I find it funny that Ingmar, you brought directly registration, because the second part is really about like how to use registration data to update population number. And the idea is that, I mean, when we go to the medical doctor, when we have kids and we put them in school, when we get a pension, we have quite a lot of information on like how many people are in which area, but it's a very confused information. And so the idea is how to bring those different data streams together to try to get like a more accurate picture. And so this is a work in Colombia where I got information from the census in 2018 and from different registers in 2018, and then I'm trying to predict the population in the following years. And one of the issues here is that, so you see first that we have the census, it's a given population, but the full population is already like, the census doesn't cover the full population. And then we have the register that covers some of the population, other that are not in the census, and not everyone. So it's really like this very biased picture, but of massive scale, because we're taking a million of people that are in it, but quite biased. And even more like difficult is that we have different registers that have different parts of the population and that are more or less like accurate for different ages. So for example, you can see here that's by age, so each point is a municipality by age and by sex. And the difference with the census is quite different, and different register shows a different picture. So for example, pink is in education, is better here, benefits is better here, and we have some that are very hard to capture. As always, is the child are hardest to capture, and the very old are hardest to capture. And similarly, we have a different of coverage by departments. So we have those Guayana and Amazonas, the very like remote places. They're not in the register. So we have really like Vishada and Lopez, like are really like remote places that are really they're not really well pictured in one register. The question is, okay, you're not very well pictured in the census, in the register, but would the difference per year inform about the population change? And so that's the question. And so there's the coverage, then there's the evolution through time. So the different challenges. There's also the idea that, and here I'm representing the education register, and there's a like 2018 to 2021, there's a massive drop in number of people registered. This is not real. This is just they have cleaned the data set potentially, or they have like changed the data set. So there is a change in the register is not necessarily directly linked with a change in the population. Then we have a dimensions issue because we have 2 gender, 4 years, 34 register, 1,000 spatial units. So how to get a picture that is valid across all those dimensions is difficult. And then we need to take into account the demographical logic. So the fact that if you had a lot of babies, you need to have a lot of mom. If you have people that are dying, so you need people that are like the survival that needs to like go to 1. You have to have dependency ratio that are logical. The dependency ratio is the number of working age people compared to the number of kids. So that needs to not evolve completely, change too drastically year to year, because demography is a weird one because it has a lot of inertia in it. It's not going to change massively from one year to the other, except for migration, which in general it has a pattern that is quite regular unless there is crisis or sudden changes. So it's slow and fast, and so to kind of try to, with all this data that is a bit biased and get the gist of it is a bit difficult. And I'm really sorry, I'm not going to show actually a model that well because I'm still working on it. So but I wanted to just bring to you, so I'm more of a statistician that is more working with Bayesian technique for that reason. For the reason that there is a lot of bias and a lot of things that are moving with data streams that are coming from different parts and trying to get a picture with some probability rather than like, I have very good target data and covariates and trying to like understand the link between the two. It's trying to get more I want observation error basically in my model. And so basically the idea is that, again, it's like simple because people can either die, be born, or move. It looks like a very simple process, and it's like a massive, it's really difficult to grasp. And so the idea is that can we have the birth registration that is biased, but not so much, the death registration that is a bit more biased, and the education or the benefit registration inform the number of people. And it gets messy quite easily, and so models are currently like running. So just it's maybe I wanted to bring more problem to you, not for you to solve necessarily. That's my job, but the benefit of using like probabilistic model to kind of try to bring all the data through together.
So, most of us here, I guess, come from more like a machine learning sort of setup, right? We would sort of have like sort of ground truth for some locations, right? And we would sort of, in a sense, calibrate our model against those locations. Is that the approach, or is the approach more here, you know what, there is no ground truth here, sort of, so, but I know sort of the biases a bit, I know this sort of overcounts a bit, this undercounts a bit, I have some sort of, priors of these things, and I put them together, and even in absence of ground truth, I try to come up with estimates.
It's exactly that. With a thing that I find very interesting is that then what you're doing, you can do some form of cross-validation, which try to predict with your model data points such as the register that are biased. Because the idea is that if you took correctly the bias of the register in your model, you would be able to predict with bias the register that you put outside of the analysis. So doing cross-validation but on the input that you kind of like separate. So you take your register, you leave a bit aside, like you leave one out, and you're trying to see that if you correctly model the bias and the process such that you can predict what the register should have observed given the model. So you can have some, so it's not one truth, but I find it very interesting, this kind of like put on the head to try to have validation still. So you have this kind of formula of data validation, and you have also more like demographic logic, and does it match to what you would expect? This is difficult. There's more. Yeah.
I have a question. Well, how do you quantify the bias? Like, is it like a number that you go up or down, or like some sort of distribution?
So there's a lot of different biases that are happening here. So one is the register bias, and here I just compare the coverage in 2018 and do a random work on it. So I'm saying the bias should be similar to what happened in 2018. So yeah, that's the main, so for all the registers, that's the main bias system is. And the question is how much, like, if you have massive cleaning, for example, would that capture? So that's what I'm trying to understand, if the bias that you saw in 2018 is a correct mean, basically, of what's happening later. With the idea that you could then, on the grand scheme of things, for stats office that would like to use this kind of model, you could do like surveys then that are checking the bias and then imputing again to like update the bias. So that's, yeah. I love to talk about something that is not finished because you can always, promise that's going to happen. So, and then I have also, so this is a bit the opposite of bias, but the stats office have done some projection of what should be fertility rate, mortality rate, migration rate, and so I use them as priors with a lot of uncertainty, and here I increase the uncertainty. So it's a bit the opposite of bias, it's more like how to inform, and typically that's where I'm at right now. I used to like really shrink it to what the stats office have done, and then I'm a bit like, this is not the purpose of the thesis. The thesis is to see if it's possible to not use the projection. So now I'm changing a bit on my head what I'm trying to show. And the last topic, and so I hope you can follow, because I don't know, I see it from the perspective of my thesis, it all makes sense, but maybe for you, you feel a bit bombarded by example on how to count people. So I hope that it does give you the broad questions that are in population estimation, both on the temporal, the geographical scale, and the data scale that currently exist. So we talked about data, we talked about modeling, and here I wanted to more talk about the insights that you can get from those models. And because I spent quite a bit of time working on Gaza and trying to understand what happened in Gaza in the first 6 months because of the data that we had. And so here is really pushing ourselves when we're a statistician or like machine learning, pushing further. It's like, okay, now I have an estimate. How can I inform? What are the insights that I get from these estimates? And so I was trying to understand the crisis response, the population crisis response, or response to a crisis across different dimensions, such as the magnitude or the pace, or different groups, or like kind of not causal, but like how do you link displacement with other variable, and also how reliable it is. So this is the crisis toolbox that I came up with. And so, for example, with the Facebook data, we can actually have a picture across different settings, and for example, comparing Ukraine and Gaza, and having a bit an idea about the differences in terms of like, what are the specificity of the crisis, and better answer, because different crises requires different response to it, as in like humanitarian response. And so, what is basically like what we can learn from this exercise is that Ukraine is a bigger country, so there are more people that moved during the 6 months, the first 6 months of the war. But in terms of proportion of the population, it's really like Gaza, it's like massive, because it's like up to 80% of the population that was forced. And so this tells you a different like perspective on how the population will be traumatized by, or traumatized, it's like beyond the psychological part of it. It's also like, if everyone is displaced, like you need a way different response than if it's like a lot of people but not everyone. So understanding that and having also the sustained part of it. So you can see here it's like the displacement rate, and you can see that it's constantly above a certain threshold. So in Ukraine you have peaks, but in Gaza it was like all the time that people were displaced. And in a way, this is a narrative that we heard in the media, but that's because that we can like actually quantify with this form of data. And what I find interesting is this data is quite actually valuable, because here you can see a peak and it's Egypt, and there was no crisis, so why there is a peak of mobility? And that's just around like National Day of holiday, Al-Fatiha, I think it was. So you can like, it's kind of showing that this data can tell you about the mobility and can also tell you about, yeah, you can compare the forced mobility across contexts. Then I wanted to see if like we can understand the differences of the mobility, or like here, interstate displacement between groups. And the data is a bit scarce because when you decompose by age and sex, you kind of like, you lose the signal. So I could only decompose by sex, or gender, let's say more. And could like split the crisis into, so the first 6 months, or the war, sorry, into 3 phases, where basically at the beginning it was clear that there was like north evacuation, the troops just like bombarded and it was clear what was happening. Then the bombardment became more scattered and dense, but with no clear guideline. And then everyone was pushed to Rafah, and they were saying like Rafah is going to be invaded. I'm sorry, I'm talking about, yeah, the war is still ongoing. I'm really talking about the first 6 months. And here what I could perceive is not completely there, but I could perceive that women were moving first when it was less risky, when it's clear that you have to move, women were moving first. And when the situation becomes more like complex, it was men that were doing the move. And so trying to, like, this kind of new data can offer this picture. And rapidly, it's like trying to understand what are the triggers of displacement, trying to understand it in terms, both in terms of anticipation. Do you move because you think that something is going to happen? Yeah, sorry.
Maybe one question. Is for the data on Gaza, is that also based on image satellites, or is it based on?
Sorry, yeah, it's so the displacement itself is Facebook. So it's the idea that the audience on Facebook changed by day, and so we could like kind of translate it into population number.
Oh, okay.
And we can translate it not so much on how many people, where people move from and to, but more how does it vary, how the number of people in one province, governorate rather, change according to another governorate.
Oh, okay.
And here it's like, so here I'm using also some form of satellite imagery just for the triggers. So I'm using satellite imagery for building damages. I'm using also data that are being collected through social media, which are press release, which is more the event. So the conflict event, that's ACLED. And I'm using also data that has been gathered on like evacuation orders. So it's kind of also social media, because they were like on social media, evacuation orders, and also the ground operations.
For the
That's fine, fine.
For the image satellites, how often do you get updates on that? Is it
So those are works that are done by, so I'm using 2 proxies for building damages done by 2 different research groups. One is based on, so I'm using monthly data, and one I know is Sentinel-2, and the other one, yeah, I guess it's Sentinel-2 as well, actually. Yeah.
Yeah, I had a question with regard to the Facebook thing. I'm sorry, I did not attend the first lecture,
sorry.
so I am not acquainted with that. Do you mean like location data that's updated via posts that are made on Facebook, or is it something else?
Sorry, I should have maybe just briefly talked about it. It's marketing. It's using the marketing API, so using audience. So you're pretending that you are an advert company, and you're putting on an advert, and basically it's telling you like the audience size, how many users on Facebook are on this age and sex category in this area.
So if you're using this Facebook advertisement platform, how does internet stability might affect these mobilities? Because if a country is in a war, platforms might be affected. Sometimes internet is down in a region, so Facebook may think that people are out, and after a while people come back, and it's increased mobility. So
Yeah, and that's a very good point. So there's two answers that two complementary answers to this question. First, internet. So that's not exactly your question, but it's clear that people are really using social media, even in a war, even more in a war. So like using that as a proxy is does work even more in a crisis, I would say. But the internet outages, so we use what Facebook themselves provide as monthly active users. That varies daily, but it's monthly active users. So there's already a smooth, so we can't see outages because, and what we understand, so I don't know if you're familiar with NetBlog, which is, I don't know who they are actually, but an institution that produce proxies of network outages, like they publish it, and so I've used that, and I was trying to see if there was like jumps in audiences compared to the outages, and I could not see anything that was related. So I think that potentially between the smoothing that Facebook does and also the fact that there are outages that people are still trying, so there are during the day outages, but they kind of have sometimes they kind of still have internet at one point. Yeah, I could not see actually, despite all the, and I know actually that they were at one point, even just to have internet, they were bringing fuel into the car, and I was like, this is interesting how they provide network in a crisis setting. They had fuel tank to just like generate the energy in order to have network. So it was weird to hear on one side that, and on the other side don't see it in the data. So I think it might be actually, I'm saying that, but there is a period where I don't have signal anymore. So actually I should say, yeah, there is a period where I lose signal as well. So.
yeah, because I was thinking it's one part that the infrastructure might be affected and the internet is breakdown from the provider, and also if people their home are ruined and they don't have access to power, so how they can just charge their battery to access to social media. I mean, this might be small differences between location to location.
Yeah. Oh, and your last sentence is exactly one of the issues that we have, is that we can account for outages that are countrywide, and I'm being very critical by saying countrywide for Palestine, but like you can see, we can account for like outages that are similar across the country. What is difficult is when it's not uniform between the countries. So the answer is from one side you can see that really like communicating with your relatives is the lifeline, and communicating with the outside world is one of the first things that they're going to try. So, but accounting for local differences, like, and so what I've done is that this paper trying to do scenarios. What if actually everyone lost? So basically, like the drop in usage in one location is not due to the fact that people are moving, but due to the fact that people are not there, and how it would impact. And because we're doing kind of a smoothing throughout the country, I think it does not doubt, like if it's a massive differences between governorate, and we are like there's 5 governorates across the Gaza Strip, this would be but it's unlikely that there's massive differences between yeah, that's how I can answer to that. Yeah.
Another question. I'm sorry, I also did not attend the Facebook data talk, but why Facebook exactly? Because for example, in some parts of the world, some social media is more prevalent than others. But I also know that these social medias also provide different access levels to their data, right? So for example, previous years, Facebook had this CrowdTangle platform. I don't know if you heard of it. Yeah, so it was something that would be helpful if they didn't discontinue it. But for example, I also see that TikTok has sort of I don't know if more open, but they have also this research access for researchers, you know.
Yeah.
So why Facebook? Given that I know that there are these limitations, why Facebook exactly?
So, and I can completely go in your way. Why Facebook is that, so first of all, we did not access that as research. We did access that kind of like pretending that we were an advertiser. So in a way that was not richer, but it was really rich information. And I keep saying 6 months of the conflict, of the war, because after I still remember, it was in May 2023, I think they changed the API. Here I can say API, because sometimes I'm like, how am I explaining what is an API? But like, okay. They changed the API attributes, and we could not access to what is called like current location and only home location. And home location is like a blend of a lot of things, so you can't see anymore. Like we collected the data, but there's no changes at all. So we use Facebook because it was available. We do account for coverage by comparing the Facebook number before the war with the Facebook with the population before the war. And Palestine, because it's like completely surveilled by Israel, has really good population number actually. Because there's a lot of surveillance, and so everyone has to be registered, and like, so yes, population number are great there. And so we account for coverage in that sense with this data because it was open. And here, maybe I should just move on and just talk about, so I'm not going to talk long about it, but because it's your question. Facebook, we lost the signal on Facebook, and then we had a project in Ukraine with WHO, and here we actually bought Vodafone data, mobile phone data. And it's richer because we get every month the number of subscribers per at a final level, so Romada, so it's admin 3, so it's quite fine. And also where they're coming from just 1 month before. And so these help us a lot with the penetration rate that you were asking for, penetration rate as in the coverage, because we can actually update the coverage rate by months, kind of the proxy being if you're coming from that, you're bringing your penetration rate with you, but then you're mixing it at the location. So we're trying to kind of account more, in a more detailed way of the differences in coverage rates through time and through geography, which again, if there is a massive network outage just at one place for long, you're not going to be able to currently, but it's completely a work in progress currently, because it's hard to integrate other form of data that can inform the fact that, there's internet outages, so therefore the number is more biased. It's trying to integrate that, but we're not yet there, where it gets just at the deterministic method of it's just a deterministic method here, and we'll bring more probability later. I'll jump because of matter of time, just to say, it's a lot of insights that we can gain from the data, and we're going to work now on how to, so those are directly numbers that we give to WHO, and then the next step is to make more social science work of how to understand how people move, at what point, so doing more social science work, that's going to be the next paper. And I just wanted to plug in here a work that I just published, which, because I worked in the population estimation field for 8 years, so I had really gained quite a lot of knowledge of the different actors and the different actors as in the modelers. So now you have more and more. So now you have more and more data on population that is coming in, because there's a lot of companies that are collecting data. Might it be satellite imagery company, might it be social media, mobile phone, and other form of subscriber data. So you have more and more and the state is collecting more data than before, as well with all this register data that I showed. So in a way, you have more and more data that is being collected, but fragmented. So you don't have anymore this top-down approach where you had really the state that was the state as in the National Stats Office, making a difference between the two, that would do a census and cover the maximum amount of people. You would have fragmented picture and that are kind of collecting your data, our data, without really telling us about it. And so that's the data collection part. And in the data processing part, you have less and less statistical offices that are actually able to access or use this data, especially in countries where, and that's what all came from this collaboration that had with the stats office in Burkina Faso, which has not necessarily the modeling knowledge of using this data. So you have more and more a weird dynamic of extracting the data from the people and then telling the government what it is the number. So, so I wanted to think about it, and I feel that population numbers are really the backbone of democracy, because the population number inform. So the census and that's a bit of a historical work that I was happy to do, is the census was before for empires and therefore for tax, for military purposes. And then you come up in the 1600s, you have Iceland that has a massive crisis, and so where there's massive famine, and so they send people actually to know, surveyors to know more what is the state of the population. So you have a change of the census more for the benefit of the people, because you have more those kings that are interested by the welfare of the people. And then you have the revolution, the French, the American one, where census become actually even a part of the democracy, because that's the way you are represented. It's how many are in this, it's the representation power. And so some demographic counts are really at the basis of how our democracy works. And so having this private company that have more power in knowing the population compared to the stats office. And here I'm making a difference between stats office and state, because the stats office normally is independent from the state. So you have really this independent body that has in order to protect the privacy, and in Germany is really important as well, protect the privacy of the people. And so, and because I'm a researcher, I was how could it look like a system that is more for everyone? Because I think that having correct population count is actually even beneficial for company, because having all those silo data is not informing how many people are there. Even company needs to know that for marketing purposes and all of that. And so the idea is to actually build a public demographic data library that would actually gather this data and make it possible for modelers to do models that are more accurate, and having people say back in the loop. And so and it was funny because so I published this paper, I was quite happy about it, but a bit oh, this is butterfly move from a researcher. And I was actually contacted by people that are working for the UN Population, United Nations Population Fund, just to say, can you actually think a bit more about how it would look, such that we can pitch and see how we can make it happen. So if you have ideas, just publish them, and people might reach out to see how to make it happen. But, and so, I did this slide just because I was thinking that maybe there were more students, undergrad students. But, so this is a massive trip into population estimation in different areas of the world, different data, different modeling strategies, and yeah, so yeah, I hope you appreciate it and like, yeah. If you have more questions, sorry, I see the clapping and I'm still talking. But yeah, if you have more questions, very happy to take them.
Yeah, thanks.